So today we are going to learn about the bisection method, and we have the equation e to the power x minus 3x equals 0, and we have to obtain roots between 1 and 2. So we start. So fx equals e to the power x minus 3x. Now the lower root or 1, so we take it as a0 is equals 1, b0 is equals 2. That is the lower limit and the upper limit, in which in between these two we have the roots of e to the power x minus 3x equals 0. So to simplify, we make a table n, an, bn, xn plus 1, which is equal to an plus bn whole divided by 2, and f of xn plus 1. Now for an we have initially 0, and for bn we have initially, for an we have initially 1, and for bn we have initially 2. So xn is equals to an plus bn by 2, which is equals to 1 plus 2 by 2, that is 1.5. Very good. Now we have to calculate the fxn plus 1, that is f of 1.5. So we place here e to the power 1.5 minus 3 into 1.5. I have already calculated the value, it's minus 0.02. Now as minus 0.02 is less than 0, therefore we shift the lower root or the lower limit to 1.5, because it will be between 1.5 and 2. So it's like this: we had 1 and 2, and we found that the root is greater than less than 0, or the negative root, so we shift the root from 1 to 1.5. If the root was positive, if this value of fxn plus 1 was positive, then we should shift the upper limit to some value between 1 and 2. So we decrease the length, that is, it was previously 1 to 2, but now it's 1.5 to 2, 1.5. So again we continue. Now our lower root is 1.5, so 1.5, and the upper root is still 2, so 1.5 plus 2 by 2, which is equals to 1.75. f of 1.75 is equals to plus 0.504. Now since it's plus, so it should be between 1.5 and 2, because the value is here equals to 0, so the root must be between some negative and positive. So it was negative here and it is positive here, so it must be between them. So 1.5 to 1.75, the value of x must be in between them, so it's 1.5 here and 1.75 here. We go again like a recursion, it will become 1.6 to 5, and this one will be equal to 0.203. We again shift the root from 1.5 to 1.6 to 5, so 1.5 to 1.6 to 5. You can understand, right? Like if it's positive, then we are shifting this to this one, and if it's negative, then we have to shift from this to this one. So if it's the value comes of fxn plus 1 is positive, then we decrease the upper root, and if the value of fxn plus 1 is negative, we increase the lower root. So since all are positive now, we are just decreasing the upper root. Again we do the same as an plus bn by 2, which is equals to 1.56 to 5, and here it is 0.08. And we continue. Since it's positive, again we decrease the upper root, and it becomes 1.5625, and it becomes here 1.53125. Again it's positive 0.03, and again we go on like this till we reach a step in which it will become 1.508125, and this is the an, and bn will be equal to 1.51625. And finally we stop here. Why? Because the previous value or the previous value of bn was same as that. So we finally stop here, and we give it out that x is equals to 1.5, or is a root of in 1, 2. We printed 1.5 because it was the question was asked, sorry I didn't mention, up to 2 decimal places. Sorry again. So the value is